Hello and welcome back to the GCSE help video. Today we'll be looking over vectors. So as you might probably know already in physics, vectors direction. So here in the first example, the one type of vectors is called column vectors. Column vectors is when they usually write it in this format, where you have to understand that this 3 is x and that this 4 is y. So on a grid, when they tell you where is this, you would just find x, find y, and it's going to be right there. And they might also give you another point, so that might be A. So B is 2, 1. How do we find 2? X. How do we find 1? Y. And it's just simply there, and you might have to draw a line in between. So this is the first type of vector. The other type of vector is a displacement vector. Displacement vectors are usually in triangles. So A, B, and C, as you can see. AB is labeled, so the arrow is pointing towards the B, so it's from A to B. Just always remember that. To A, going this way, if you wanted to label it. And CB, going from C to B, as we can see, is going to be B. Now, in this situation, how would we find C to A? So we need to find this path. Well, another way to look at it is how can we use these two values to get from C to A? So what we're going to do is go all the way around, because the vector value is going to be the same, because vector is looking at magnitude and displacement. So it doesn't matter how long it takes to get there or the shortest route. All the routes are going to add up to the same. So we're going to have B. To get from C to B, we're going to have B. And then to get from B to A, we're actually going to do the opposite. So what's the opposite of 2A? It's just going to be minus 2A. So we're going to write CA is equal to B minus 2A. Another common question examiners may ask you about column vectors is to find a certain value from one point to another point. So this is P here and this is Q, 3, 2, 6, minus 10. What we do here to try and visualize this is we're going to just draw the points. We're just going to draw the points P and Q. And we're going to label them, and we're going to do this, and we're going to label them very nicely. So now we can visualize it better. What do we need to do in order to get from P to Q? Well, simply is you're going to find the difference in between. So what's the difference between 3 and 6? We're going to add 3. What's the difference between 2 and minus 10? We're taking away 12, because we're going down 12. We're going down 12 here, and we're going to the right by 3. So the final answer, remember to always write it in this format, keep the same format as before, is 3 and minus 12. Just like that. And so yeah, here we still have vector proof as we went through before, and we're going to go into the harder question. So this next question is just the really hardest questions that they could ask you in vectors. So it's vector proof. Vector proof, we have to prove something here. See the end? This is the really hard question. So at the start, we have it pretty easy. So what is O to C? So well, we know this is A, so this also must be A, because you can see that they're parallel. They're all parallel. They're all facing this one way. So what's O to C? Well, we're going to take this path around, or even this path around. And we're going to see that A and B give us C. So O to C will be A plus B. So simply very easy like that. So now that we know that, how can we find from B to A? Well, all we really need to do here is flip that around, so we get minus B, and we can get a plus A on that side. So because we're going from here and then there, right? So we're going to get A minus B. Now, how do we work out D to F? Well, we look at D, we look at F. How could we do this? Well, we could take the long way around. So we got B facing this way, A facing this way, another A, a B, and another A. So what does this give us? Well, we've got minus B, because at the start we need to flip it, minus A, because we need to flip it, another minus A, we're going to need to flip it, and then two B's, so plus B, and plus A. So what does this give us? So we got plus B, and minus B, so this will just give us a normal B, and then minus A. Another way we could do this, just to show you that all the vectors will add up to the exact same. This is A, this is A, that's B, and that's A. So here we've got two minus A's, so minus 2A, or minus A and minus A, whatever works. And then we got plus B plus A. What does this give us? B minus A. So all vectors will add up to exactly the same way, no matter what path you take. We took this path once, and we took this other path another time. Doesn't matter. They will all add up always to the same. Now we get onto the harder topic. Because it's showing that EG and DF are parallel. So we're just gonna erase this to make it a little bit easier. EG, what is EG? So first we need to find EG. So we're crossing all the way over there. So we're still gonna find A, B. So we got negative 2A, because we're going down to A, plus 2B. It's just simple, still very simple, negative 2A plus 2B. And then for the next one, DF. Now DF, what is DF? We've already worked it out. B minus A. Now, what we need to know about vectors is when they're parallel, they will have the same amount of A's and B's. They'll have a ratio, right? So here we have negative 2. If we take it out of the whole equation, we'll have 2, to the times minus A plus B, which is exactly the same as 1 minus A plus B. When they have this number, when you can take out a number like minus 2, like 1, imagine, from these two equations, this shows that they are parallel because these two inside brackets are the same. So this tends to trick a lot of people because they don't know how to do it. Just make sure to memorize this. And one last, thank you so much for watching, and remember to subscribe.